All right, so I'll be going through some of the lower food web today. And so just kind of an overview, I'll be touching base on a lot of the things that you'd expect to see in a lower trophic food web talk. But three of the things I want to highlight that are highlighted here: the spring total phosphorus, the spring chlorophyll, and the mysis. And there was a lower trophic task group a couple years ago, and these were three of the most highly ranked things in that report that would indicate that if there were imminent changes going on in these, those could suggest that there might be something going on that could affect prey fish production. So these were really highlighted in that report, so I just want to make sure that we touch on those. And we'll also be touching on some differences between the nearshore and the offshore, and a few of the things we'll be looking at some of the seasonal patterns that happened this past year. So we'll start out with dry-scented mussels because there's always a lot of interest in what's going on with them. And as you can see, this is from a lake-wide survey that happens every 5 years, and if you can see the little dots all over, those are the sampling stations that are hit every 5 years. You can see we're not a zebra mussel system anymore, we're a quagga mussel system, and it's pretty much been that way for a while now. Going back to the last two surveys, the 2010 to 2015 survey, we see things kind of are not changing all that much like they had been, say, between 2000 and 2005. And so what we're seeing, this map is mussel density or mussel numbers per square meter. And what we're seeing is the mussel numbers are actually pretty much stabilizing or even decreasing in some areas. So that's good news that our mussel numbers are kind of flattening out. The thing that is not happening though is mussel biomass isn't necessarily stabilized yet, because most of the mussels in the deep offshore areas are very small. So it's a very young mussel population in the deepest areas of the lake, which is much of the lake. And so those mussels are continuing to grow. So even if they aren't adding new mussels, the biomass is still increasing. So we really haven't stabilized in terms of biomass yet, even though the numbers are in many areas are stabilized or even decreasing. From that same lake-wide every 5-year survey, we can look at diparia numbers. And if you remember way back, diparia were the primary benthic invertebrate in the lakes. They're a high lipid food source, very important for fish as a prey. And in the late 90s, early 2000s, their numbers just took a dramatic decline where we declined from 10,000 per square meter in some areas to basically zero. Going to the most two recent surveys, we see not as much is changing now just because there isn't a whole lot out there. But one thing that has changed between 2010 and 2015 is in the central part of the lake and here, we lost half the sites between 2010 and 2015 where diparia were found. And in the southern basin, there's only one site right there in that deepest spot where diparia is found. So we lost 8 of the 9 sites where diparia was found. So we're still, in a sense, still seeing some decrease in their spatial coverage, even though things have kind of leveled out at very low numbers of diparia in the lake. So jumping into total phosphorus, as you remember, this is one of those highly important indicators in that lower trophic report. And this is from the EPA spring offshore lake-wide survey that takes place every year. You can see we saw real steep declines of phosphorus in the late 90s, early 2000s. Right now, we're just kind of bouncing around kind of year-to-year variation where in the offshore, it seems like we've kind of landed where we're going to land in terms of our spring total phosphorus. Next, looking at spring chlorophyll. Again, one of those important indicators from that lower trophic report. Chlorophyll is used as kind of a dirty way of just thinking about, quick and easy way of thinking about pelagic production. So it's not necessarily primary production, but it's an easy way of thinking about the productivity of the system. This again is from the spring data from the EPA lake-wide survey, but this is actually satellite-derived chlorophyll for May. The reason we look at May is because that's when historically we had our spring diatom bloom, which was a really important feature in the lake. And you can see again, much like phosphorus, we had declines in the early 2000s, but now we've kind of leveled out where we're going to be, it seems like, where there hasn't been a lot of variation from year to year. So even though we're stable, we're at much reduced levels than we used to be. These levels are close to a half a microgram per liter. That's really, really low chlorophyll. So what's going on in the near shore? The near shore is a little bit harder to get a handle on. Part of the reason is just things change so much in the near shore. And just to kind of give an example of that, we have two of the NOAA near shore sites that we sample. One is at Muskegon. That's located a little bit south of where the tributary comes out into the lake, so it's not under direct influence of the Muskegon River. And the other one's off Grand Haven, right out in front of where the river comes out. And that's the Grand River, so that's one of the most important sources of nutrients for the lake, right off the Grand. And so we see with total phosphorus here, another part of the problem with the near shore is that the data sets don't go back as far as like they do for the offshore data sets. There just isn't as much data. For the Muskegon one, you can see really it bounces up and down from year to year. This is the spring total phosphorus. No real trends, even going back to 2000 in that data set. So just a lot of year-to-year variation. At that Grand Haven site, there's not much going on over the last 5 years, but compared to 1996, that spring phosphorus is much, much lower than it was in the mid-90s. If you had the 70s numbers, it would have been even higher. This is incredible high phosphorus. I can't even imagine something like that right now. I would assume somebody did something wrong. Going back and looking at the chlorophyll, it's pretty similar to what we saw with the total phosphorus here at the Muskegon. Not as much data, a lot of variation. It might even be a little bit higher now than it was in the late 2000s at that Muskegon station for the spring chlorophyll. The Grand Haven station, a little bit of variation over the last 5 years when we've been working at that site, but compared to 1996, much, much lower at that site. So what's going on in the near shore kind of depends on where you are, and I think that would be true no matter what sites you picked in the near shore. It's going to kind of depend on where you are. But this Grand Haven station is interesting just because that's right off of the Grand, which is one of our important sources of nutrients and productivity. So what do this look like over the course of the year, just to give a context of that spring data that we focus on. And this is offshore chlorophyll over the course of the year at a Muskegon offshore station. So about 10 kilometers offshore and 110 meters of water. You can see right here where we should have a spring diatom bloom, we don't. That's pretty consistent. And this is for 2018. And actually our highest chlorophyll in the surface mix layer up in the epilimnion was in November in 2018. So basically at the end, almost at the end of the year is when we had our highest chlorophyll levels. So very, very different from in the past when they should have been around May. If we had those two nearshore stations that we just looked at, you can see they have elevated chlorophyll in the spring compared to that offshore station. What's interesting is this blue line is the Muskegon nearshore station. You can see though by late summer and into the fall, that nearshore station isn't much different than that offshore station. As you go through the summer. The Grand Haven station, you can see it's generally higher than that nearshore Muskegon station. The other thing you see is with that nearshore data is it can be all over the place. And that's because those nearshore stations are influenced by the currents, tributary runoff, storms, upwelling. Anything that happens disrupts those stations. So that's part of the reason they're a little bit harder to get a handle on. So we'll jump into some of the zooplankton data. And this is August data from the EPA Lake-wide Offshore Survey. So this is late summer data from the EPA survey. In the top we have biomass, and in the bottom it's percent composition. And what you can see is much like many of the things we already talked about, in the late 90s, early 2000s, we saw some declines. So we see declines in biomass right there. Pretty similar to what we saw with phosphorus and chlorophyll. More recent data, it's kind of bouncing around up. We have some peaks and we have some valleys, but it doesn't look like it's really shifting dramatically in one direction or the other in the more recent data. This goes through 2017. The one thing to keep in mind though is back in the late 90s, if you look at this data, this red here is Daphnia, so a large-bodied cladoceran. These two blues are calanoid copepods. One of them is limnocalanus, but that's just a great big calanoid copepod. So those are all calanoid copepods, where it's almost an even split back here in 98, whereas now where it's much more of a calanoid copepod dominated system. And so why that's important is calanoid copepods live in much colder water for the most part than cladocerans. They have lower P to B ratios. So if you had the same biomass of cladocerans and calanoid copepods, those calanoids would have a much lower production rate. So when you shift to calanoid copepods, you're lowering your zooplankton productivity even if you didn't change your biomass. So shifting it to those is a big deal in terms of the composition, in addition to the overall declines in biomass that we saw. So just to kind of put some of what we saw from that summer survey into maybe a context of what goes on over the whole course of the year, this is data from the Muskegon offshore station. And on the top, we have the seasonal pattern through 2008, or for 2018. And then on the bottom, we have the annual mean for each year. So that's basically data collected March through December, the annual mean value of biomass for this station. You can see in 2018, there's nothing terribly remarkable about that year in terms of its biomass. We've seen, much like in that the August data from the EPA, we have some peaks and some valleys. It's kind of an average year over these 12 years. But again, all these years are generally much lower in your biomass than we had in the 80s and 90s. So lower total zooplankton biomass. If we look at how things went during the course of 2018, you can see our peak biomass in zooplankton was in September and October. So in the fall is when we actually have our peak biomass of zooplankton offshore. And that's when the Daphnia, those cladocerans, move into the population. And it's important to notice that if your peak biomass of cladocerans is in the fall, you're going to have a lower productivity because the water is cooler than if your peak biomass was in, say, July when it's warm. So it's important that that peak is in October and not something like July or August in terms of production. Another thing I want to just mention, they don't show up here, but we consistently caught holopedium in our samples. In the last 12 years, we hadn't caught any holopedium, at least in our subsampling. And that's a cladoceran that has a little gelatinous sheath around it. It looks like a piece of snot, really. And they're usually more common in Lake Superior or Lake Huron, generally considered to be more prevalent if you have more acidic conditions or less productive conditions. So it may be a fluke that we got them this year, but it's something to keep an eye on just because they can indicate other water quality issues going on. Looking at zooplankton over the course of the year and across time at that near shore station, this again at Muskegon, you can see over these last 12 years, not a whole lot of variation. 2018 was maybe on the high end for these last 12 years, but certainly not as high as what we saw in the late 90s, early 2000s for a high year. The interesting thing here is, one, it's very low yet in May at a nearshore station, which is somewhat surprising because it tends to warm up a little bit quicker than the offshore. But then we see peaks in June and then in October. So a little bit different of a seasonal pattern than what we saw in the offshore. These top bars, I just want to highlight, are veligers. And so we have a pretty high veliger biomass at this nearshore station, and they were there through much of the growing season. The interesting thing is that our shallower stations, even though there's quite a few veligers, we don't see good recruitment to the mussel population. Whereas at the offshore station, we don't have as many veligers, but we see good recruitment into the mussel population. So having veligers doesn't necessarily mean good recruitment into the mussel population, and not having a lot of veligers doesn't mean you're not having good recruitment into the mussel population. So sort of a dichotomy between the nearshore and the offshore that we see. Next, looking at predatory cladocerans. Now, one of the reasons we look at these is because if you have low fish conditions, predatory cladocerans can be an important, if not one of the most important planktivores in your system. In the offshore station, typically, these blue is Bithotrephes. So Bithotrephes, the spiny water flea, that invasive zooplankton, is typically the most abundant predatory cladoceran in the offshore site. You can see 2018 was kind of a weird year where we didn't have very many Bithotrephes, and we have pretty good contributions from Cercopagus, which is the fish hook flea, which is a smaller invasive water flea, as well as from the native Polyphemus and Leptodora. So kind of an unusual year in a sense. And what happened is we hardly had any Bithotrephes early in the summer during 2018 at this station. They really never got going. And they typically do peak in the fall, but they really didn't build up as high numbers as they do in most years. The other thing that happens is usually Cercopagus isn't out there all year. Usually it's only out there early in the year at our station. And they persisted through most of the year. So usually if something weird is going on with Bithotrephes and we haven't had any time to really look at it, it's usually temperature, which I didn't think was all that weird this year to have caused this, or maybe something's going on with fish. Bithotrephes are super vulnerable to fish predation, so if fish predation was higher for some reason, that could keep Bithotrephes numbers down. Now looking at our nearshore site, unlike the offshore site, at our nearshore station, Cercopagus, or the fish hook flea, is the most abundant predatory cladoceran. So they're smaller than a Bithotrephes. They probably have a little bit different diet. Actually here we catch where the first year that they were in there, you see how their numbers exploded. They dropped, and they just kind of are bouncing around from year to year. So no major trends going on in their numbers. But the interesting thing is even though Bithotrephes aren't abundant at this site, they were almost absent in 2018. So that's consistent with what we saw at the offshore site. At the nearshore site, when there's Bithotrephes, they're usually here, and they really never showed up. And it is sort of unusual that Cercopagus persisted as long as they did at this station. So there's something different going on in what controls these predatory cladocerans last year. Finally, looking at mysis. Again, this is one of those important indicators from that lower trophic task group report. And the reason it's considered important is because with the declines of Diparia, mysis is your large-bodied, native, big macroinvertebrate for fish to be feeding on. And a lot of fish do feed on this and still do feed on this. This data is from the Muskegon offshore station. You can see over the last 12 years, we've had some peaks and some valleys. 2018 would definitely be in the valley. It's the lowest year that we have here. All these years tend to be lower than what we had in the late 90s. So considering that we've had ups and downs, I wouldn't say that this is necessarily completely alarming, but it's definitely something to keep an eye on to make sure that it doesn't stay down there. There are a few other surveys that take place during the summer. So once that data is available, that might help shed light into this, and we should start sampling in the next week or two here to just see if that low numbers persist into 2019. So just to kind of summarize, not a whole lot happened with most of the things that we looked at, including total phosphorus and chlorophyll, some of those important indicators where things have kind of stabilized with a lot of the things we look at with the lower food web, but they stabilized at lower levels than that they had been previously. So they haven't necessarily recovered back to high levels. They've just kind of stabilized, and we may be where we are with some of these variables. We haven't seen any recovery of Diparia, and that's of concern. Just a few things to keep on the radar, just if the sighting of those holopedium in our samples, if that's a fluke or if that's just a sign of further changes that makes Lake Michigan more and more like Lake Superior, just because they're an indicator of different water conditions. I think we need to keep an eye on the mysis just because those low levels, if they persist, that could be of concern because of their importance as an indicator. And then finally, just where's the mussel population going? If we have stabilizing or even declining numbers, where are we going to land in terms of that biomass, especially in the offshore regions? That's it.